So, good afternoon, everyone, and thank you for joining us today for this virtual presentation on the topic of data warehouse, data lake, and data lake houses. Um, Let us maybe start by introducing ourselves. I'm Hajar Habjaoui. I'm part of the Global Black Belt Organization for Analytics in Microsoft. So my role is to be the technical advisor to our customers for their new analytics projects. So basically, we ensure that customers, they have all the information they need, that we unblock any technical blocker before they start working on their projects with us. And so with me is Naveed.
Thank you, Hajar. Hi, everybody. I'm same as Hajar in the team of the GBBs, which is the Center of Expertise and Excellence here at Microsoft for Cloud Scale Analytics, covering the data and AI portfolio. So we look after the data and the analytical products here at Microsoft, and pleasure to be with you all. And hopefully we'll be sharing some food for thought as our presentation goes through to make you learn things or two. Thank you. Over to you, Hajar, back.
Thanks. So before we begin, I want to encourage all of you to ask any questions that you have in the chat during the presentation, and we'll try to answer them as they arrive on the chat. And so before we start, let's discuss the goal of the session. And the topic of this slide will probably be familiar to some of you. Today, we categorize 4 types of data analysis, which increase in difficulty, but also provide increasing value. So you have descriptive, diagnostic, predictive, and prescriptive analytics. These techniques, they help us make sense of data and use it to inform decisions. So descriptive analysis will help us summarize and understand the data that we currently have. Diagnostic analysis will help us identify the root cause of problems. Predictive analysis will help us forecast future trends, for instance. And finally, prescriptive analysis helps us make sense, make decisions by recommending actions to take. And so today we'll dive in and explore some of the tools that have been used over the years to be able to provide these types of analysis to business users. And today we'll be exploring 3 key concepts. So you'll have data, we'll talk about data warehouses, data lake, and data lake houses, and where they fit into the broader landscape of data-driven applications. So throughout the session, we'll explore as well the various compute and storage engines that power these data architecture approaches and examine real-world application where they are most effective. So whether you're just getting started with data analytics or if you are a seasoned pro, I'm sure that this session is going to offer valuable insights in the world of data architecture. So without further ado, let's get started. Analytical solutions, they've been developed for as long as computers have been in existence. In fact, the concept of a data warehouse was first mentioned in the 1970s, I think. So the need for analytical solution, data unification, a single version of the truth, and a historical repository of transaction has been present for a very long time. And that's precisely what enterprise data warehouses promise to deliver: the ability to ingest data from various different sources and consolidate it into a common analytical platform. So data warehouses, they've been developed precisely to address this need for centralized analytical platform that can aggregate data from various sources, including, for instance, OLTP databases that are spread over their IT ecosystem and other sources, and provide that single source of truth. This approach is especially useful for business intelligence application, BI application, where you need a reliable and consistent source of data. So think about financial reporting, for instance, and the thing that we have more is that the data warehouses, they've been designed to support high concurrency and low latency requirements, which is essential for any modern analytical application. So for instance, it supports ACID transactions. It ensures data integrity that is maintained even though you have high concurrency and you have high transaction volume environments. On top of that, data warehouses, they provide tools to optimize queries, such as indexes or materialized views, so that it improves performance and speed up the analytical processes. You also have like data warehouses that are also pretty strong in terms of governance and auditing capabilities that are included that to ensure that the data is properly managed and secured. So all in all, data warehouses were an excellent solution for organizations looking to consolidate the data into one single analytical platform while ensuring data integrity, performance, and security. However, when we ask customers, how successful were your data warehouse projects were? Many of them report that it's been incredibly time consuming, it's been driven by IT, it's been slow, and it was really burdened with the static data models. On top of that, it was usually very expensive to store data in a proprietary setting that is only tailored to business analysts. So very difficult for data scientists or for ML AI use cases to grow in that kind of environment. So as a result, for instance, incorporating new types of data such as unstructured information was extremely challenging. And that's how slowly the data lake concept has appeared. So let's delve into the history of data lakes. So what is a data lake? It's a storage repository that can hold a vast amount of data in its native raw format, and that is optimized for scaling to terabytes and petabytes even of data. What was the initial promise of data lakes? First, data unification. By providing a single data platform for real-time and batch analytics, a data lake, it helps organizations to quickly and efficiently process and analyze large volumes of data. And that's very critical for businesses that need to make decisions based on really up-to-date information. The data lakes, you have simplicity and no fixed data model. So it's really easy to land any type of data in that storage because you don't have that overhead of ETL before that. So you just dump the data there and then process it as you go. Data lakes they provide a single platform regardless of use cases and data. So one of the key advantages of a data lake is that it supports all type of data. So whether it's structured data, semi-structured, unstructured, it makes it an ideal solution for use cases that need to process and analyze data from, those new types of sources, such as social media, sensors, or for instance, IoT devices. Data lakes are designed, for instance, to enable ML AI or streaming use cases for real-time insights. It's inexpensive. On top of that, it's inexpensive storage. Another advantage of a data lake is its cost effectiveness. Because you decouple compute from storage, it enables you to store petabyte scale data very cheaply, while providing the ability to quickly access it and analyze it with the tool of your choice. And finally, it provides the ability to do data ingestion from hundreds or thousands of systems without transformation. So finally, choosing to go for a data lake to store your data is kind of future-proofing your data ecosystem, because you can ensure that your organization's data can adapt and scale to meet your evolving needs. However, data lakes, they come with their own set of challenges that needs to be addressed for them to be successful. And that's why we're going to look into some more information on how to organize data in a data lake and what are some of the best practices to build data lakes on Azure. So what you see on the slide is the standard way of organizing data in a data lake. Why this topic is so important is because you're planning to store so much data coming from different sources and having so many different people or processes access it, that you need to make sure that you know very easily where to find the data and how to give access to people in a simple way. So we'll read from left to right. So first you have the raw data. So we organize the data lake by layers or by data stages. And so the raw data is the landing area. You don't do any transformation. The data is supposed to stay as it is. In streaming use cases, for instance, you will make sure that the data is aggregated so that you don't have too many transactions. And that's kind of your reference. So you won't give access to that many people. And it is supposed to be organized mirroring the ingestion patterns. So basically organizing by data source, for instance. Once you have that raw data, what you will do is that you'll have processes, hopefully mostly automated, that will enrich that data, transform it, and land it into the enriched data layer. That layer, in there, you'll have, the formats. The formats of the file are harmonized. So for instance, if you have Excel or CSV in the raw data, you might want to make sure that you choose one format that is that makes sense in your use case. You'll have a common data model. Schemas are going to be defined. You can validate the data types. That's usually where you can start giving access to data analysts or data scientists to the data. So you kind of cleaned up a bit the data, you harmonized it, you make sure that the formats are coherent. And then from there on, that's where you get the added value, because when you start using the enriched data, you will use processes to make it consumable to users and store it in the curated layer. So you have good documentation, you have good data governance to make sure that you get access to to keep documentation of the data that you have. You have maybe a data catalog so that end users can find the data, and the structures is really well defined. So for instance, that's where you have KPI calculated. And so that's I think that with other companies, they call it the gold layer. That's where you'll get, data visualization engines plugged into it for visualizing. And finally, that area, you have the workspace layer that is more about if you need additional data sources, for your specific use case, or if you have a group of data scientists that have, run some models and they have some results that they want to be able to store and reshare after that. So that's the workspace area. Some people call it the sandbox as well. And so what I wanted, in relation with the previous slides, organizing your data in your data lake is probably one of the first best practices that I will share. Please plan the zones, plan the folder structure in advance, so that when you start using it and when you start storing data, you don't lose it. You don't spend a lot of time finding the data that you need. Same in the same concept, you also have the security groups that are supposed to mirror, your organization, and also the folder structure. If we look into the raw data layer, remember, like the reference data, make sure that you don't change anything. Keep it in original format. Some companies, they use the immutable feature because you want to make sure that whatever you write on that raw layer doesn't get changed. Because whatever happened with the processes afterwards, if there is any problem, you can still go back to your reference. Make sure that it's highly secure. Not ever, like, very few people, very few processes need to access that raw data, only for processing to the enriched layer. And the pattern that we see is that data will land, a process will get kickstarted to transform and then load the data into the enriched layer, but then no one uses it. So if you have lifecycle policies, so policies that we say, okay, if there hasn't been a change for 7 days, just store in the lower tier. So for instance, in colder storage, not in hot, will help you to reduce costs. So you have the original format in raw data, but then on the other areas in your data lake, we see the trend of going for Parquet and Delta formats, mostly for performance and compression purposes. But I'll let Naveed dig a bit deeper into that topic later. Make sure that in each folder you have the same file format. So remember, in the enriched layer, you want to have something very coherent, so that you don't have too many differences. You don't have to, like, you go for one file format, maybe not for the whole data lake, but at least for use cases or for, or for areas in your data lake. So try to keep the number of different file formats very low, so that you don't have to do a lot of conversion afterwards when you need to work with the different data. Okay, same. Use consistent naming convention. That's in the same category as the best practice before. And one of the best practice that I want to share, but it's true for data lake in Azure, but with most big data engines, make sure that you optimize the file size. Large files are always better than smaller files, because we've seen patterns in which, for instance, for IoT, that you have a lot of small files and it creates a huge overhead during processes and analysis of the data. So for cost purposes and also for better performance, you are better off having larger files, but a smaller amount of them than the other way around. A lot of big data engines are optimized for it. And you'll see, like on the slide, you have a few recommendations on the optimal size for the files. Now we're looking into, we're doing a bit of, we're looking a bit more closely regarding security, because those are, like, this topic really has to be known a bit in advance. Why? For the first point, make sure that you assign relevant permissions as early as possible. So you have to think about security very early on in your development process. Think about how you're going to give access to which group. Do they need to manage the resource? Do they need access to the data? What you don't want to do is to split your data in a way that, for instance, I'm a data analyst, I need to ask access to I don't know, 50 different data sets because the data has been split all over the place. So you have to make sure that you have the right security group, that you make it easy to give access. So here you have a few rules to make it a bit easier for you. So you have the concept of role-based access controls to like in Azure, in which you can give, you can give rights to manage a resource. And so in the case of, for instance, Azure Data Lake Storage Gen 2, you can use it to manage the resource, but it also gives you access to the data. So the recommendation here is use it only for access for admins that are going to manage the resource, and for the data access to use what we call access control list. So basically every folder and every storage account and every container has a list of groups that can access it, and so that's how you can get you can provide fine-grained access to the resources. So that you will use for users and jobs. Of course, make sure that you restrict the right permissions, except for the sandbox area, because it's going to be built for a smaller scope, really for a team, for instance, and for automated jobs that we recommend having as much as you can. Please use security groups. Don't add individuals to access control lists, because you have limits on the number of assignment that you can do. So I think it's like 40 or something. So you'd rather create security groups for it and then assigning individuals to them so that you don't ever reach that limit. And finally, and that's something that I already said before as well, please make sure that the access to the raw data is restricted. I know that data scientists, they really want to have access to the data at the earliest that they can, but the raw data layer should be kept untouched, except for ingestion and processing and ingestion processes. And so here we're going to, after all those best practices, I'm just going to do a little sum ups of, the realities behind most of data lake projects. So we already touched upon it a bit in the best practices. So limited visibility and how to find the right data. So that's one of the biggest challenges, actually, is that they can easily become dumping grounds for data, and it's never actually analyzed or mined for insights. And that's what we call data swamps. And that's because there is a lack of very strict rules or where you store the data, of integrated or holistic views across the organization of what you have in that data lake. So it makes it really hard to understand what is stored there, what I can do with it. What you have, one of the other challenges is data duplication. So data is ingested multiple times and copied and transformed many times within the different data lake layers. So it's very hard to keep track of the different versions, and that impacts the cost as well. If you ingest the data 3 or 4 times, then you can expect that the storage costs are going to increase as much as this. You can have some performance issues. So think having too many small files versus bigger files can impact the performance. It can be very complex to manage and monitor, because I've had customers having petabyte scale of data, and so just to get the information of the size of a folder, it would take hours to run a script to get that information, because it was so big. It was taking a lot of time. And you may have some slow query response times as well. Funny, the next point is kind of funny, because the fact that there is no data model is also the fact data modeling was one of the cons for data warehouses because it was too strict. But data lakes is because there is no data model. The challenge, like the lack of scheme or descriptive metadata, can lead to a lack of semantic consistency across the data. It's hard to do data modification. You have limited support for ACID transaction. So it can lead to data quality issues and reliability issues. For instance, just copy pasting data between folders. If you have a process run like writing in the data, it can create inconsistency. So it can be hard to guarantee the quality of the data. And so to avoid these challenges and make the most of data lakes, it's important to address the issues head on. So you want to look at proper governance, metadata management, security measures that should be put in place in advance, along with tools to address the slow query response time and reliability issue. And so to conclude, both data lakes and data warehouses, they have served us well. And I don't think that either of them is inherently bad. It's all about how people implement it. And in fact, it's possible to successfully implement both technologies. However, with the advent of the Lakehouse, you can actually benefit from the best of both worlds. And that's what Naveed will be talking you through right now.
Thank you very much, Hajar. And I'll take the screen share over. Let's see if everything goes as planned. And please, if you can confirm that you can see the slide deck and the share. Okay. Yes. Thank you very much.
It looks good.
Thanks,
Yep.
Thanks, Matt. Thank you, Hajar, and hello again, everybody. So I'll be talking about the third concept. So we started with data warehouses, its history. Then we dwell into the data lake house, that how we can build the cheaper version of the data warehouses by using them as an augmentation tool to kind of like overcome the shortcomings of what data warehouses has due to the rigidity and give some fluidness by providing a massive storage and processing area to build patterns such as data lake houses to augment archival processes, ETL offload, and use as data refinery or data exploration grounds. So there is always like a hunt for a silver bullet in the software engineering terms, that we are always looking for one tool which can slay the beast of the complexity of the systems, whether they are transactional systems, whether they are analytical processing systems, both of them. So that effort resulted into a leap towards a lake house design or a lake warehouse design. So rather than a data warehouse design, the traditional classic structured processing, towards data lake, which is kind of like more non-model based data processing, to a lake house, which is kind of like getting you the best of both worlds, that you can rely on the beauty of the warehouses, that slickness, and also the vastness of the lake houses. So that data lake houses. So that basically gave birth to the concept, which is lake house or a lake warehouse. It goes by two names. And what it has basically been made of is called Delta Lake. So what Delta Lake is, so Delta Lake is a storage processing pattern built on top of Data Lake. It gives you kind of like the best of the both worlds of warehouse and a data lake house. And in this, what happens is like the file format for the storage which is being chosen is called a Parquet file format. A Parquet file format is a storage format in the big data world from the Hadoop backgrounds. If you have heard about the RC format, which is heavily used, and then it was ORC format, the optimized row columnar format, and then there was like a Parquet format, which was the only columnar format. And that is efficient way of using the data, because all the columns which are queried together are combined in one kind of like a physical file data model, and then it gives you greater compression and greater kind of like of flexibility. If you talk about what kind of a compression, I talk because previously Hajar was alluding to this fact, you can get like 10:1 kind of like format comparison. So if you have 1 terabyte of the data, it can be compressed somewhere around 200 gigabytes. So it gives you good compression formats as well. And remember that Parquet is better suited for read operations than to write operations. So there are some issues in there, and especially when Hajar was alluding to this fact that you have lots of small file problems, which is mostly happens in a message-oriented system and using real-time data, which comes in a short burst in a micro or a macro kind of like data movements. You have to basically work for that, and there are some resolution patterns such as compaction there, which does basically allow you to do that. But then again, compaction is a pausing process. When you're doing it, then you will not going to be accessing that part of the data because it is getting kind of like in a bigger, larger format for easier reading. That's basically how it goes. So this Lakehouse is built on Parquet, and now the implementation of that Lakehouse using those Parquet storage and processing format was done by many companies, many kind of like innovators, the vendors, they have done it. One of it is called Delta Lake. Now, Delta Lake is done by Databricks. They kind of like, it's an open source format, but it's basically been developed and researched and invented by Databricks. And it is the same format here in Microsoft we use in our One Lakehouse architecture as well. And that is basically is the most popular format so far, which you can actually use to implement lake warehouses. So what it is, so we'll be reading the slide from top to bottom. Let me get a laser pointer so I can point out when I will be talking to you. So the first format it is like, what is Delta Lake? So Delta Lake is a storage processing format built on Parquet, developed by Azure Databricks, and Microsoft uses the same as well, though we add our side of the optimizations to it, and they have their own optimizations to it. And they being Microsoft partners in Azure Cloud, you can use and have the option to use any one of them. And because you can use our products and our partner products, so that kind of like an architecture we call and go by the name of Microsoft Intelligent Data Platform, or MIDP for short. So what is Delta format? So Delta format is providing you on the files some indexing capabilities and statistics. Why they're required? Indexing is a great way of accessing the data in a constant time manner. Else it would be very difficult to gauge performance and make them usable, because when you're talking about best of the both worlds, you want the long haulage queries to be running, but you also want your interactive queries to be basically available to your applications and to your end users. So for that, you have to maintain indexes and statistics. So when that indexes and statistics capability was applied to those Parquet for storage column formats, that is basically one tick in the box to the right direction. Then it provides you the transaction log as well. So the transaction log guarantees you the acidity. Acidity means like it makes sure that you get the atomicity, concurrency, consistency, isolation, and durability in there, so that you can help get the ACID transactions, and also enables you to do time traveling. So time traveling is one of the bit is like when you're making your data lake, which is immutable, to Delta Lake, which is mutable, then you need to basically do the time travel in there. It gives you the MVCC, the multi-version concurrency control of the data version, so that you can access the data as it's changing and can record that how the data has changed over the time. And also we need to basically now coming from inserts model to an upserts model. That means that like you can update as well as insert. So if the record exists, you have to update it and create its history. And if it's not there, then you do an insert. So that basically is a operation you have to do. And then again, because Hajar was also telling you that there are modelless when you are on data lake. So if you want some kind of like a model alignment, so the schema enforcement on top of your Delta Lake tables, that basically is one of the other key figure as well, to make sure that your data is conformed to a standard format of which you will be accessing later. So that is basically the top bit of it. So if we dig a little bit into the detail what it is. So first of all, Delta Lake, just to tell you, it gives you an ACID compliance on top of your analytical systems to make them behave like if they're like the transaction processing system. So you can do more kind of like usage of the big data systems in terms of the old-fashioned data warehouses or the database system. So it gives you the best of the both worlds. First of all, it's an open source, open format. It provides you the full ACID transactions. It gives you or enables you to have to implement your streaming and batch, the full batch and mini micro batch kind of like processing. It adheres to the schema enforcement if you want to basically have those schemas to be tightly complied to it. It allows you to do snapshotting of the data through which you can do the time traveling so that you can go back to the data in period of time. And then it also supports natively your data modification operations, such as updating the data, deleting the data, and merging the data in place. That is what happens. So now the processing engine on top of Parquet is Spark, and it is an optimized Spark, again, both by Microsoft and Databricks as well. So it's not the open source Spark. So it's kind of like open source, but then basically further hardened and optimized for Delta Lake operations. So Delta Lake, just think of it as like Parquet files with transaction log capabilities been built in. And then basically the processing engine is Spark. And it also gives you Z-order indexing and statistics for your faster data access and management, and compactions to optimize files so that your smaller file size problems go away, and gives you the skipping of the data to stay at the relevant pace so that you can kind of like get constant time operations or near time constant time operations, and also the caching capabilities for your frequently or most frequently used access data so that you basically can run system into an interactive manner as well. So that is what Delta Lake is. That is one of the way of implementing Lakehouse. So if it's one of the way, what are the others? So the other storage engines, which are basically built on top of the same Parquet format, is one is called the Apache Iceberg, and the other one is Apache Hudi. Now, these are the two kind of like competing storage engines going in there. So like I said, Microsoft and Databricks are vested into Delta Lake, and rest of the competition, they're basically kind of like using like Snowflake, they're using Iceberg, and the open source community, they're more kind of like favoring the Apache Hudi side of the things. And then for the compute engines, like I said, we basically use the Databricks Spark or its Synapse Spark, and we have the native format import into Power BI data marts as well. And then from the other competitive world, you can basically use the Dremio or the Flink or Spark, open source Spark, to basically implement or kind of like use these engines. So that is basically how they are technically implemented in the world of compute for big data processing and implementing lake warehouses using Delta Lake. So I will go in next 3 slides about what, why, and how of the Lakehouse. And before I talk about these points, I presume these slide decks will be shared with you. And when they will be shared with you, please look at the links at the bottom through which you can further dig into the details and read at your own pace for the material we'll be presenting. Having said that, what is the Lakehouse and its shortcoming solution? There were some problems with Data Lakehouse, the management architecture, and to adding a transaction storage capability on top of that, and how to use similar data structures and allowing data scientists and coexist with the machine learning processes and to support all those open formats which Data Lake had. So these were a couple of challenges why what basically were faced by the industry. So why we needed a lake house to address those problems, to enable you some transaction support, some schema enforcement, some BI support on the raw data or to the source data directly. And storage should be coupled from the compute, the openness, the diversity of the data types, but still you have to basically make a structure, because without structure, nothing is there. If your data doesn't have a structure, you have to apply the patterns to find the structure to make meaningful information, and to support the diverse workloads and to support end-to-end streaming of the data, whether it comes in large bursts or the shorter bursts. This is something which was needed. So all the people, so the data analyst can harvest rich insights by using it through a de facto industry language such as SQL, or the data scientist can do machine learning modeling development and can do kind of like their clustering computing of the data or the classification of the data or the deep model learning trainings that basically should be enabled out of the box in a tool or manner what they want to use. And the data engineers, they can build ETL pipelines as well, the ELT pipeline, and a mix of both. So they can basically do extraction, transformation, and loading, which is a narrow down process, or extraction, loading, and transformation, which is a widener process. So that all are supported out of the box, and that's why Lakehouse became the talk of the town and became to realization. So how we implement these things? So in data warehouses, what we had structured data only. We did the traditional ETL tooling, bring the data into our data warehouses. On top, then we run our business intelligence and reporting KPIs. That's how it was done. When data lake came in, what it gave, it worked as an augmentation tool. It widened the capabilities of your data warehouses to cater for your semi-structured and unstructured data. And then you can deploy your own compute, like Hajar was telling, to do your data science, machine learning, or BI reporting to traditional analytics. What Data Lakehouse gives you, it gives you kind of like a one lakehouse architecture. So everything goes into your data lake, which has one of the questions which I answered by somebody, I can't remember the name now on the chat window, that it has the metadata and the governance layer, that question you're alluding towards, that should not be an issue in the lake warehouses. And then you basically deploy the compute on the same kind of like set of data with different slicing and dicing. So this is basically how it's implemented. And to implement it, you have got three flavors. You implement it using Hoodie, Iceberg, or the Delta Lake format. So a versus comparison between all these three concepts. So traditional data warehouses, they were costly. Lake houses were cheaper, and data lake house, because built on lake house, that basically is the same. They all are open format, apart from the data warehouses, which are closed proprietary formats from all the vendors. Scalability, well, you can scale from the volume at a larger scale, virtually infinite. However, in data warehouses, that was not the case. So, but again, it's all relative when you talk about it, because nothing is virtually infinite. But the bit is like the way you design your system to be scalable, that matters the most rather than the technology. Intended users usually for the data warehouse was limited to data analyst, and the data lake houses to data analysts, data scientists, and machine learning engineers. And the data lakes were mostly for exploratory or data refinery. So they would like mostly for the data scientists to do cleaning automatically or manually. Reliability, data warehouses had high quality and reliability of the data. Data lake house, because they're trying to mimic both the best of the world, it has the high quality and reliability thanks to the governance process baked into it. And also some in the data lake, again, you can have high quality data, but what Hajar told you, that to avoid being a data swamp or a data landfill, it just basically needs to follow some practices which he shared with you. Ease of the use, again, data warehouses are very simple, same as with lake houses as well. However, the data lake is quite difficult to kind of like get to a business ready or business adapted or business plugged in kind of like a state, because it's mostly raw. So you need to basically build structures and layers on top of it to do that. If we look at the performance of the data lake being, because you have to do all the heavy lifting in the compute, it was poor. However, with lake houses or warehouses is quite high. However, I would say I should have basically put highest here and higher here, and that would have been a better reflection to it, because lake warehouses are not perfect as well when it comes down to low latency and high concurrency, because you still have to look at the warehouses. That's why still there are hybrid architectures in process, which I will show you in the next slide. So when you're implementing a lake warehouse or a lake house, what should you do? I mean, like, you have to implement all the best practices of the data warehouse and the data lake, because it's a combination of both. So what does it mean? It means that use the lake data lake as a landing zone for all data. Keep your data private, adhere to your governance and provenance specifications before it enters the data lake. Secure it by using all the techniques which Hajar has alluded and she has pointed us towards, and then build reliability and performance in your data lake by using the Delta Lake pattern for storage and compute. And also catalog your data so it's easily available and is managed. These are the best practices on top of the data lake practices which Hajar has suggested to you. When we talk about a picture, because picture speaks 1,000 words, how do at Microsoft, we are technical advisors, we advise our customers to build such lake houses. This is the architecture. What does it mean? This is the Microsoft Intelligent Data Platform architecture. You have got your hybrid system across all the data into one data lake. Your open and governed data lake foundation is built on top of this by using Synapse, which is one of our product for data analytics, or you basically use Databricks, or you can use both of them together depending upon the use cases. And then you basically land your the technical workloads, not the industry workloads, for data engineering, real-time and streaming, machine learning and AI data science, SQL-based analytics, data warehouses, traditional and enterprise BI. And again, we give you the right tools of choices there to do that. So you can use Synapse, Databricks, all of them together or not. You can use Azure Stream Analytics and Synapse Analytics streaming, or you can use Spark structured streaming. Same goes with machine learning. There are multiple tools available to you, so you can use one or all of them or some of them depending upon your use case. You can use Databricks machine learning workflows. You can use machine learning from Azure ML, which is Azure machine learning, or you can use Synapse ML. And when it comes to SQL, then again, you have an option. You can go with implementing the Databricks SQL, which is more kind of like a Spark SQL sort of a things. Or you can want to be more ANSI and T-SQL compliant, then you can use SQL Serverless, which is more kind of like a traditional SQL you're used of. And if you have in the Lake Warehouse issues with some high level data concurrency and low latency, then you can still deploy the traditional SQL dedicated pools from data warehousing through Synapse to optimize those use cases. When I talked about optimization, just let me read the last column here, this vertical, which is Enterprise BI Analytics, which is Power BI, we use it, but you can use any of the tool of your choice. Having said that, if you come in here, this is basically how you build it in Delta Lake. With the medallion architecture, you can build bronze, which is the raw layer, silver, which is the integrated data layer, which is kind of like a technical modeling of the data, and your semantic gold layer, where you can kind of like build your star or snowflake schemas to kind of like make it more business ready, to then start using it into your compute engine, which then can be again Databricks based, or it could be Synapse based. And here, which is basically the Synapse is sitting here at the element 8. What it means is like that all those use cases which require high concurrency and low latency, they can go through from here. So you can have an architecture molded or augmented in a way that it kind of like suits the need what you're doing. So this is one of the architecture implementation. You can use it as a reference architecture. If you browse Azure reference architecture, you'll come across tons of architectures Microsoft has deployed with their customers and partner networks, which have been shared in the open source, and you can basically utilize them. So that was one of them. So where does data lake, sorry, not the data lake, the lake warehouse fits in? Well, it's not for everything. You have to basically qualify the things for the use cases. The best use cases so far are for your data science use cases across the board, your data engineering with flexibility to do both ETL and ELT kind of like processing. And if you want to do analytics on an unstructured data, they're good for kind of like those use cases. But if you want to do structured, still, I think warehouses have the place. They are not replacing each other. They're only supporting each other. And reporting with caching layer due to latency, that like if you want to have a direct source reporting need, that direct method of reporting can be supported by lake warehouses to fit in there. So these are those bits of guided nudges for you to implement lake warehouse, because there's a misconception that, oh, when big data came in or data warehouses are dead, let's build a 10 cent or a $10 or a cheaper data warehouse. Yeah, everybody tried, but be honest, where did we go? No, data warehouses are still there. Same goes with lake warehouses. It gives you a back flexibility of both. So you built you got an SUV with a sports mode, but again, look, it's not a sports mode car because the way it's built or the architecture and all that massiveness it's got. The sports car is slick. So it means you have to kind of like figure it out the way you are doing that and choosing the right tool. So there will be, for some foreseeable future, I will not say never because I could be proven wrong, but there is no one tool which fits all or one shoe which fits all sizes. So you have to kind of like pick and choose one over the other intelligently, and the heavy lifting goes through architecturing and Microsoft Intelligent Data Platform with implementation towards lake warehouses is a good place to start and start thinking about. By that, I would like to say thank you and would like to go back to both of us if you folks have any questions. And again, look, if you don't have any questions, I would like to thank you, you, the attendees, and the organizers for giving us the chance to speak.